Hey, it's Professor Dave. Let's learn about light.
He knows a lot about the science stuff. Professor Dave explains.
Since we've been able to look up at the sun, we've been aware of light. As darkness is one of very few things that we instinctually fear, we have always bestowed light with godlike properties. But for all of antiquity, we had no idea what light really was. Figures like Newton and Huygens worked with light in the 17th century, but a more sophisticated description of light, which we call classical electromagnetism, was developed largely by James Clerk Maxwell in the 19th century. This theory depicts light as a transverse wave composed of oscillating electric and magnetic fields, which are at right angles to each other and perpendicular to the direction that the wave moves. We will learn more about these fields later. Just like the kinds of waves we have previously discussed, electromagnetic waves have amplitudes, wavelengths, and frequencies. But instead of different frequencies producing different pitches, like sound waves, different frequencies of electromagnetic waves produce different kinds of light. If the light is visible, these frequencies will correspond to different colors. Frequencies greater than this will exist as UV radiation, X-rays, or gamma rays, and frequencies less than this qualify as infrared radiation, microwaves, or radio waves. All of these phenomena are collectively referred to as electromagnetic radiation, and they can be found on the electromagnetic spectrum. Here we can see all the wavelengths and frequencies ranging from radio waves to gamma rays, and we have found some technological use for all of these in modern society. Even though they seem dramatically different, some requiring things like antennas or other equipment to manipulate, all of them are fundamentally the same thing as the light you can see with your eyeballs. They are just of different wavelengths. All electromagnetic radiation moves at the speed of light, which is about 300 million meters per second in a vacuum, the fastest speed possible in the universe. This is fast enough to get from here to the moon in about a second, and since we know that all waves move at a speed that is equal to their wavelength times their frequency, this product will be equal to the speed of light for any type of electromagnetic radiation. How is it that electromagnetic radiation is produced? To answer this question, we have to learn about electric fields, which are coming up soon. For now, let's check comprehension.